Oh, hi everyone. Welcome to our first virtual lab. This is our first experience. Hope we will not encounter any problem. Should you encounter any problem during the course of the lecture, please let me know using the chat feature on the Zoom conference. During the course of the lecture, we may hear background noise. We are in a different location, and some people may have kids in their room. They may have like pets or a dog, and I don't want to any interruption. So what I'll do is I will mute everybody, and if you have any question, please use the chat feature on the Zoom conference, and I'll respond to either respond to the entire class. Everybody will see, or I can just send you a private message. All right. You can send me also private message if you don't want to everybody to see your question. All right. So what I'll start with is this is the same as just face-to-face lab, all right? In the sense that we will have 1 week to do the calculation, all right? You'll have 1 week to do the calculation. For example, to tonight's work, I expect you to complete the calculation by same time next week, that is Thursday, April the 2nd. You will have to turn in the data sheet along with the post lab for this lab. I received an email regarding the post lab for lab number 8, PK over weak acid. I didn't pass out the post lab. So don't worry about the post lab for number 8. Moving forward, you will see in on Canvas folder for post lab. I'll have the data sheet. I'll have the post lab Word document. All right. I'll have the Word document on the folder for post lab. That is where you will submit the post lab assignment. For pre lab assignment, all right, just like face to face, you'll have to turn in the pre lab file Canvas on the same folder where you download the Word document. All right. Please do not email me. I receive a lot of emails. I have 5 lab sections, and if I receive emails from all the students, chances are your pre-lab or data sheet might get parted somewhere. So if you submit through Canvas, it will go automatically into the folder, say for example, folder for pre-lab. And when I go create it, I'll just find your pre-lab or data sheet or post-lab in there. One other thing is, you've been, some of you have been using the pencil to collect the data in the lab. I have no problem with that. But this time around, I'll recommend that please use ink in your calculation. Use pen, because when you submit, sometimes when I print out or I may not be able to read, based on the resolution of the screen I'm using. You know what I'm talking about? If the resolution is not that good and use a pencil, it will not come out clear. So please use ink. If you make a mistake, you can cancel, that's fine. You can use an extra sheet of paper and label the numbers and say, oh, this is what I'm trying to do, or I made a mistake. You can cancel, it's fine. So use ink. If you did not and you have submitted, that's fine. I'll try to uh, create your work the way it is. All right. So remember that. Don't worry about post lab number 8. I have post lab number 9, which is for tonight's experiment. I'll walk you through what we're going to do today on powers and calculation. I'll recommend that please do have your lab manual next to you. Please have a plain sheet of paper or lab or your lab notebook. All right. If you have a notebook or any notebook or scratch papers, please have them, or even the printer papers, so that you write equations and some of the important information you will need for calculation. For calculation. I hope we will not have any problem with internet connectivity. If you haven't submitted anything on Blackboard, what I'm going to do right now is share my, I'm gonna share my screen with you guys, and I'll show you where things are in terms of what to turn in. Can you see my screen, please? Somebody say yes. Can you see my screen?
Yes.
Yes.
All right, yes, that's what I wanted to make sure that you know we are all on the same page. If you look at what I was trying to do is how do we turn in any work, say post lab or data sheet. So it could be obvious for some of you. This is an example for introduction to chemistry lab, where they had to go to a folder for this particular experiment. You will see submit assignment tab on any work, be it data sheet or post lab. This is where you will submit your work. You don't have to print out the work. If it is in one document, for example, pre-lab, if it doesn't involve calculation, you can just type in there. But the reason why I recommend printing out is you can use your hand to set up the calculation. It might be difficult to write equations, all right, multiplication or exponent, say for example, Avogadro's number. Using the Word document, it might take long, especially in dimensional analysis. You can just use a pen and proceed with calculation. And if you don't have a scanner, all right, you can take a picture and save it on, save it on desktop, or you can attach also through your mobile device if you're using iPad or um, any other smartphone for that feature. Or you can go to App Store or Google Play Store to just see if you can find the free scanner I've used before. Free scanner app, you can scan the document and just attach. So that's how you will be turning in the data sheet, the pre-lab, and post-lab assignment. Don't worry about post-lab assignment number 8. I didn't pass out before we did, before we went on lockdown or quarantine. All right. So that's how you're gonna be doing what? You will be submitting the data sheet and the post-lab. Other than that, one announcement is I did make the sets of quiz available. Please take note of the due date. I gave you 1 week, just the way you did the file set of quiz. You may see that quiz number 1, quiz number 2, and 3 are not available on your gradebook. It will be available. There's a reason. For next week, they will be, don't worry about like, oh, the grade went down or what happened to my past 3 quizzes. It's just gonna come back again. Please concentrate on the sets of quiz and try to get it done before midnight on next Sunday. Next Sunday, I think this coming Sunday. You have until midnight, 11:59 Eastern Standard Time. Eastern Standard Time. So as far as our experiment tonight, if we were to come up or come to lab, we could just perform experiment on calculation of the pH and power capacity. Before I explain what power is, I want you to go back again to your lab manual. Doesn't have enough information, but I'll recommend that use any general chemistry book to read on pH calculation. I know you know how to find the pH of a solution for an acid or for a base for pOH. Using the equation you see at the top here, this is how to find the pH for pOH you have pOH equals to negative log of hydroxide concentration. You are expected at this point to know or differentiate between an acid and a base. All right. It's not that you always use same equation. So you should know which species an acid, which species is a base, so that you use the appropriate equation in this uh, case. pH equals to pOH. I mean, pH equals to negative log of hydronium concentration or hydrogen concentration. Apart from that, you should be able to differentiate a weak acid and a weak base. In general, Chem 1, you have to list um, different types of acids, categorize them as a strong acid, as a strong base. You should be able to do that. You are expected to remember that this is an acid, this is a base. If you have taken the acid and bases in the lecture, you remember that Ka, pKa, Kw, and so forth. Ka is for weak acid. So apart from just going by the name, such as hydrofluoric acid, it is a weak acid just by memorizing them. HCl is a strong acid. How do I know? By memorizing from the literature. Sodium hydroxide is a strong base. How do I know that? It's in the literature. Apart from that, you can look at the text. Inside there, you'll see different acids with different Ka value and Kp value. Those acids with Ka or Kp are weak acid. And the way you find the hydronium concentration for a weak, all right, for a weak acid, you don't use this equation. Before you use the equation up here, all right, before you use this equation right here, you need to determine the concentration of A dihydroxide or A dihydronium, A dihydroxide or A dihydronium. For example, if you want to find the concentration of hydronium this is for a weak acid. For a weak acid, how do you find the hydronium concentration? It's given by the square root, all right? The square root of Ka times the concentration of the weak, I meant to say concentration, you know, this is concentration. And this is the generic formula for weak acid, the generic formula for a weak acid. This gives you the equation to find hydronium concentration. So if I'm looking for hydronium concentration, it is H3 O positive, all right? This is positive. This is concentration of hydronium in a weak acid, and you have the square root sign here. You'll have the square root sign here. Don't have time to, write this square root sign. Therefore, with this, you'll do what? You'll find out the pH of a weak acid. We're gonna be dealing with the weak acid today, all right? And we will be required to find the pH of a weak acid. How will I find it out? It is not based on this equation you see at the top on the PowerPoint slide. This is the PowerPoint slide I'm talking about. This is for a strong what? This is for a strong acid. For a weak acid, you need to find the hydronium concentration first by multiplying the Ka of a weak acid times the concentration of that weak acid. Of course, you know the concentration is the same as molarity, right? Molarity equals to number of moles over volume in liters. just so that you know where we're gonna get the Ka value. If you look at page 149, look at page 149, there are acids we are going to work with, all right? We have their molar masses, we have their chemical formulas, and the pKa value, all right? pKa value is to find the Ka, what? To find the Ka value for the acid, all right? How do we find or relate from, find the pKa or Ka of an acid. All right, this is how you will find the given. Let me get out of this screen. Given the pKa, all right. Let me use the little space I have here to show you how do you convert from uh, pKa to Ka. Ka is given by what? Antilog, anti what? Anti antilog of Ka. All right. Was pKa 10 raised to negative pKa. So, or rather, this is 10 raised to. This is 10 raised to 10 raised to negative what? P what? pKa. I should have used this symbol. I get to see 10 raised to pKa. So this is 10 raised to negative negative pKa. So there's a raise right here for the pKa. All right, Ka equals 10 raised to pKa. All right, so the equation, yes, this one. Somebody saying you use this equation. There is a sign here to put for raised to in the on Ka. That's how we will change. Look at page 149. Because of those values, you see 5.2, 8, 4.73, 4.792, and 7.198. Those are the values we will use to find the Ka of our acid so that we find the pH of the weak acid. So what you need to remember, I haven't started yet. Now, if I go back to our PowerPoint slide, I want to caution you on the significant figures. There is a difference how you handle significant figures in acid and bases is totally different from typical, significant figures concept and calculation. If you look at this calculation, forget about the example number one. All right, the concentration has two significant figures. So pH should have two places of decimal. The number of significant figures in the concentration of hydronium is the same as the number of places of decimal in your pH value. So if we are to find the hydronium concentration in this case, 10 raised to negative this value here, and then we round off to two significant figures. It is important, especially for your lecture, all right, where maybe the instructor is just running the Scantron, and you know the equation, all right? It is easy, but significant figures might throw you off. If you look at this equation here, all right, or this example here is asking you to find the pH of 6.7 times 10 raised to, I think, negative 4 hydrochloric acid, HCl. Your calculator will give you, so many digits, more than what you need for calculation. And somebody might select B or whatever you may select, or you will be like, oh, how is it? Because this one has two significant figures, pH will have two places of decimal, and in this case, the correct answer is D. So you will calculate the pH for your solution, and please pay attention to how significant figures are maintained, how significant figures are maintained. It's the same thing on the work example in the lab. There was, if you look at page, if you look at page 142, look at page 142. There is a work example towards the bottom of the page where the pH, right, the concentration of acid and bases has three significant figures, and the places of decimal has three places of decimal. So significant figures and places of decimal, more so when you'll be doing your calculation, pay attention to that. All right. So so far, so good. I'm done with the component of the pH. All right. The pH, of solution here. All right. Any question on the pH? How to find the pH? Remember, pH of a solution is a function of, is it a weak acid or is it a weak base? Got to answer that. All right. We will see down the line where those two equations are applicable, where those two equations are applicable. I will make this data sheet available on Canvas so that you may want to, if you get stuck and you want to ask me a question, you will say, look at how do I proceed with equation 6 or line 6 for that matter. You will have to refer to the equations. There are about 50 something equations. This is the only lab which I usually caution the student that you need to get started with the calculation right away. Otherwise, you may forget down the line. All right, before I walk you through our calculation for every section, a power solution is power solution is a solution which receives change in pH. Okay, we all know what a power solution is. A solution which receives change in pH. Now, power capacity is the ability of a power to receive pH, or the number of moles of either weak acid or strong, number of moles of a strong acid or strong base added into a power solution in order to see significant change in pH. It's not that it will receive change in pH forever. No, at some point it will no longer receive pH, and at that point we say that we are beyond the power capacity of that solution. So scientists or chemists actually prepare power solution in a lab using using a strong, a weak acid and its conjugate base. You will never see, or you will never make a solution, a power solution using strong acid and strong bases. So if I have a solution of sodium acetate, she'll have equal concentration. All right. If I have a solution here of 1 molar acetic acid, all right, CH3 to draw with. This is acetic acid. This is acetic acid, 1 molar. All right. And if I have 1 molar sodium acetate, this is the conjugate base. 3, this is 3 here. C O O, and then N, what? Na, like that. This is sodium acetate. If you look at here, equal concentration, all right? Equal concentration of a weak acid and its conjugate base. When you remove sodium from this sodium acetate, you will end up with the conjugate base, and this is an acid. So basically, we don't have this Na to end up with a power solution. So if I have this solution right here of equal concentration, I have myself what we call a power solution. Shall have equal concentration. So what happens when you add a strong acid, for example, HCl? You have HCl, you add in this solution right here. This is an acid and it will be neutralized by the conjugate phase in the solution, and there will be no change in pH of this power solution. If I have a strong base, say NaOH, sodium hydroxide, if I add into this solution, it will be neutralized by the weak acid. So you have to look at it that what will happen. It's just similar to what we are talking about, stressing the solution. Where will it go? So this will produce hydroxide, which will combine with hydrogen to form H2O. All right, and this will react with hydrogen to form hydrochloric acid in it to form neutralization reactant. In the end, there will be no change in pH of a power solution. So if we were to come in the lab, we will collect the data, and from the data, we calculate the power capacity of different power solution, I'll recommend that please have your lab manual, because I'll be referring to the procedure, okay, to get some values for calculation. All right, the values you have on the data sheet, somebody came in and did the work and partially filled the data for you. You assume that you came to lab and you collected the data and you are ready to do the calculation. That's all what's happening on the data sheet you have, all right? The values, the numbers you see on the data sheet compared to your lab manual, the one I sent to you, or if you compare to what you see on the screen with the actual in the lab manual, the values you see here is assumed that you came in and collect the data, which you are supposed, of course, to use the pH meter. All right, you're familiar with the pH meter we used before, and the lab consists of three parts. There is part one and there is part two. Part one and part two and part three. Part two, preparation of a power solution. Part three, hydrolysis of a salt. Let's see what's going on part one. Part one is to see determining the or looking at the pH of a strong acid and a strong base. A strong acid and a strong base. In this case, a strong base is sodium hydroxide. Sodium hydroxide, and a strong acid is hydrochloric acid. Hydrochloric acid. That is what we need for part one. And without wasting my time, in part one, working with the strong acid, strong base. The value you see here, all right, the value you see here, these are the measured values. What does measured mean? It means somebody came in on the lab and used the pH meter to determine the pH of a solution, which is sodium hydroxide and HCl, and these are the values. These are the values you see here. Now, in the data which will go on item number one here is the calculated pH. How do you calculate the pH of a strong acid and a strong base? You know that from the equation here, pH equals to negative log of hydronium concentration. If you're determining the pH of The strong base here, it is negative log of what? Negative log of hydroxide concentration. So I'll say negative log of hydrogen or hydronium concentration. That is what we need for part or item number one. That is item number one. For item number two, all right, item number two, let's see here, if you are looking at the item number two for strong base, this is what is you need, not hydronium, it is hydroxide concentration, that is all you need for item number two. How do I know that, or what is the concentration of hydronium or hydroxide? If you read the background on page 145, you are asked to find, take 25 or 5 ml of 0.1 molar. So read the procedure. It gives you, or it states the concentration of each one of them, the molarity of each one of them. You are working with 0.1 molar HCl and the same value, 0. What? 0.1 molar NaOH. So that's how you will determine the constant the hydroxide concentration and hydronium concentration in order to find what? In order to find the pH and pH. This is calculated. Now, common sense right here. Let me see if somebody can just think of what is going on. I'm gonna mute everybody here and we're just gonna have a discussion on, how you will find the pH of the mixed solution. Once you mix a solution of strong acid and a strong base, neutralization will take place. What do you expect the pH of the solution of strong base, strong acid? Equal amount. What the pH will be, how will you calculate, or what is the pH? Complete neutralization. Can you hear me? Can you hear me? What is the pH? Oh, let me just, all right, let me see if I can unmute you all. All right, let me see if I can unmute you all and see if I thought I unmute. Can you hear me? Hello?
Yeah.
Yes, I can hear you. So my question is, since we are all on the same page, how will you find the pH of pH of a mixed solution? Remember, you are mixing strong acid and a strong base for item 3. How will you find the pH? Remember, this is neutralization. Think of equivalent point. What is the pH at equivalent point of a strong base, a strong acid? Hello? What is the pH of, technically at equivalent point for a strong acid, strong base?
7.
Yes, exactly. Thank you. Somebody just save everybody. All right. Amy Patton, thank you. I didn't see the chat. Yes, it is 7. The reason why I'm bringing up that to everybody is you may get stuck and say, all right, you showed me equation for line 1 and line 2. How about equation 3 right there? That is what we expect to remember, that, neutralization will take place and there is no moles of acetate, will be no more moles of the base, and the pH is supposed to be 7. That's all for part 1, and please show the calculation. And as I said, you have to show your work, remember there is significant figures, significant figures. What I want to do is erase here so that I have space for part two. Any question on part one? All right. Part two is preparation of a power solution. All right. Power solution of phthalic acid or KHP, potassium hydrogen phthalate. All right. And the chemical formula you see, there are some information you are expected to remember and to recall from the lecture. And this is how to find the molar mass. I don't want you to say, all right, this is what it is. I have potassium, I have hydrogen, and I have, you know, the phosphorus. So in this section, somebody prepared the solution based on, all right, based on the direction. The molar mass, if you look at page 145 on the direction, before I show you how to calculate the pH over solution, item number 4, somebody went in the lab and took 0.82 grams of, all right, 0.82 grams of potassium hydrogen phthalate. With the molar mass of 204.3, that's what you are given. The molar mass. The reason why you have two values, you will need to find the number of moles. Into a Clyde dry big and dissolved in 40 ml of deionized water. We will have to keep track of the volume so that we need to calculate the pH of the solution. Potassium hydrogen phthalate, okay? And they dissolve. So that was dissolved in 40 ml. If you look at the number of moles to make a power solution, all right, they added NaOH 0.1 molar, 0.1 molar. We need first of all to find the number of moles of potassium hydrogen phthalate. What is the number of moles? You know, moles is given by mass over what? Mass over molar mass. Mass over molar mass. So if these are the grams, all right, before we come here, before we come to the calculation of the pH, right here, we need to find the number of moles of phthalic acid, which in this case, this is for line 5. Line 5 is, look, line 5 is given by a mass in grams, all right, in grams, divided by molar mass. That is the equation for line 5. For line 5. So basically, this is the mass. This is the mass of the acid, and the moles of the acid is given right here. Now, molarity of the phthalic acid solution produced. Molarity, all right, molarity equals to number of what? Number of moles, all right, number of moles of volume in liters, volume in liters. This is the equation we need for molarity of phthalic acid produced. From line 5, you'll get the number of moles. All right. Now, where is the volume in liters? Which volume are we going to use? If you look at the direction on page 145, you know the volume. What is the volume of the acid? What is the volume used to make the acid? In line 2, what is the volume used in line 2? What is the volume? All right. What is the volume of the acid? H2O used to prepare. All right. Prepare acid solution. What is it? What is the volume? Look again on the direction, because if we don't get this right, down the line, it will be difficult for us. Yes, to find the molarity, we know molarity equals the number of moles over volume in liters. You can use the chat feature to respond to my question. Thank you, Kiera. Yes, it is 40 ml. So if it is 40 ml, change that to liters. You know how to change the volume to liters. All right, Clan, thank you. Teamwork, okay, 0.04, yeah, you divide by 1,000. That will give you the volume in liters to determine the molarity of the acid, All right, volume of the acid solution used to make the powder. So how was the powder prepared? Volume of the phthalic acid used to prepare the powder. On page 145, to form 145, step number 1, part P, to form your powder solution, you will need to convert 50% moles of the acid present in your solution to, all right, into sodium phthalate, that is the conjugate base. Whatever we have in the number of moles or the starting number of moles, we should change or convert the half of the number of moles into the number of moles of the conjugate base by adding strong base, in this case, sodium hydroxide. So if we have 40 ml, we will add 20 ml of what? 20 ml of NaOH, 20 ml of 0.100 molar NaOH, so that the strong base being added here will convert some of the moles of the what? Of the weak acid into weak conjugate base in order to end up with a powder solution. All right, in order to end up with a powder solution. Remember, powder solution is made up of a weak acid and its conjugate base. So we started by preparing just a solution of a weak acid, which in this case is phthalic acid. We want to convert half of it into its conjugate base, and that's why we are adding a half of all right, a half of NaOH, number of moles of NaOH. It will convert that into its conjugate base. So line 7, volume of acid solution used to make the powder solution. All right, out of that, volume of phthalic acid solution used to make, you know, the volume. of phthalic. It is, you have given there, we did it before, that's what you need to put it in there. Phthalic acid solution, 40 ml. Now, molarity of NaOH here, you need to read the direction. Look at page 145, because you may say, where is it? It is given in there on page 145, molarity of NaOH. Look at item 1B, part 2, 1B, part 2. 1B, to form your power solution, you need to convert 50% of the molar or moles of phthalic acid present in your solution into sodium phthalate conjugate base of phthalic acid. To do this, measure out 20.0 ml of 0.100 molar NaOH solution. That is being asked in line 8. Line 8, molarity of NaOH solution. You need that value. And I see it is very significant figures, 0.100 molar. Line 8. Now, volume of volume of NaOH used to make a power solution is still on the same paragraph. It is given in there. The number of moles. So 8 and 9, look at the data sheet or read the procedure. This is from the procedure. All right, that's what you need to do for line 8. All right, for line 8 and line 9 right there. For line 8 and line 9, that is what you need to figure it out from there. No calculation. You need to find out those values from the manual for part 2. Now, line 10 is to find the number of moles of NaOH used. From the molarity equation, number of moles is given by molarity times volume in what? Volume in liters. That is the equation for line 10. You know the molarity of the acid, molarity of NaOH, all right? Volume of NaOH in liters, you gotta change that to liters. Now, if you think of what happened when you add NaOH into the solution, all right, into the solution, it will give you the number of moles. So if we know the number of moles of NaOH, added into the phthalic acid solution, it will convert a half of the number of moles you started with. So at this point, you will take the number of moles of phthalic acid minus the number of moles of NaOH. That will be the number of moles of the conjugate base. All right. The number of moles of the acid is not the same as the number of moles, when we divided that. No, it is not that. All right. It is not the number of moles we are talking about here. Species molarity, that is molarity of the protonated and the conjugate base. That is when we mix the solution, or when we mix the NaOH and phthalic acid solution, what will be the molarity of each one of them. Remember at this point, we started with 40 ml of the acid and we added 20 ml of the base. The total volume at this point should be what? Should be 60 ml. 40 ml of the acid plus 20 ml of NaOH. And remember, those number of moles of NaOH will convert into the conjugate phase of the acid. So if I know the number of moles of the acid remaining when making the powder solution from the original number of moles of the acid and the number of moles of the phase, you will have to find the molarity of each one of them and place on these pucks right here and right here. So for 11, let me just see if I can write here 11. Let me say 11 so that you see it will be uh, number of moles or moles of what? Moles of acid remaining. Once you convert to that, divided by total of volume in liters. That will be the molarity of the species. Molarity of the species. So if I'm looking for acid, that is what it is. For 11 or 12, all right, it is the number of moles of conjugate phase divided by total, I mean to say total volume in liters, total volume in liters. So this should be V lowercase, if you want to, and this one should be just T, total volume in liters. So here, species molarity, remember the number of moles of NaOH added will convert a half the number of moles of the acid you started with. And how do I find the molarity of each one of them? It is the number of moles of acid remaining over the total volume, which is 60 teaspoons. You should have total volume. That value will just come right here and here, okay? It will just be 11 and 11 and 12, 11 and 12. Any question so far? If you just join us, some folks join the conference in the middle of the lecture, you can use the chat feature to ask any question. So before I walk you through step number 13, all right, before I walk you through step number 13, let's go back to 4 here. Remember, talic acid is a weak acid. And this molarity, you will end up in line 6 right here. You cannot say, all right, let me use this equation. You cannot use this equation at the top right here and say negative log of the molarity you have in line 6 in order to find the pH of your solution. No, it's not going to work like that. This is a weak acid. And the way you find the weak acid, I mean, pH of a weak acid is not the way you will proceed with determination of pH of a strong acid. How do I know that this is a weak acid? One way of identifying a weak acid is if you are given the Ka. If you look at page 149, KHP is one of the weak acids because I have the Ka. I can find the Ka. I've given the PKP. You'll never see Ka or strong acid or strong bases. So for line 4, let me go back to line 4. I'm going to delete this equation right here, or this setup right here, and go back to 4. Please write somewhere for line 4 here, all right? I skipped that before we dive into number 13. For line 4, this is a weak acid. And we do not use the equation you are familiar with, negative log fast, find, all right? You need to find the concentration of H, that's concentration of hydronium ion, all right? Concentration of hydronium ion. Concentration of hydronium ion is given by This is given by this equation. Where is the square root sign? Somebody who is tech, I'm still trying to see, but let me just write QR for square root. You have to put a square root of this. Under the square root sign is the Ka of the asset times now, let me see, let's say line what? Line 6, the value will get from line 6. Everything under that will give you the hydronium concentration. You'll see somewhere in the text giving you this equation. They might have different approach, but this is the way forward in finding the hydronium concentration from uh, for a weak acid. It summarizes the ice table. I know maybe some of you are familiar with ice table, but I have to find the Ka, where Ka is given by what? Is given by somebody say we need use the raised sign. So this is 10 raised to, all right, 10 raised to. Yeah, I got it now. Thank you for whoever gave me this hack. I'm now hacking. So 10 raised to pKa. This pKa is given from page 142. This is on page 149. 149. That is how you'll find the Ka to plug it in this equation. Where are we getting all this? To expect you that you have covered this concept in the lecture and just applying in the lab. So once we know now the hydronium concentration, you will now say therefore, all right, therefore pH, all right, pH is given by the negative log of hydronium concentration. That is how I will find the pH for the phthalic acid, for the phthalic acid. All right, that is the setup for line 4. It may be a little tiny square box, but that is the equation. Hopefully you are writing your own notes, writing it somewhere. I have numbered the boxes so that we are all on the same page. I'll make this document, not the way with the equation you notice this, but I'll make this document with the numbers just in case somebody gets stuck during the week. You can mail me and say, oh, how do you proceed with equation 13, for example, and then I know which exactly you are talking about. Instead of just saying in part 2, how do I find the molarity? So I don't know if this is the molarity you're talking about. I don't know if it is the molarity of which one of these guys. All right. Any question on line 4 or equation 4? That is what you will need to do for line 4 here, behind the screen right here. This is what you need for all right? What you see here, it is for all these, all right? For all the calculation we have done here, all right? It is for this line 4, this tiny box right there. This is what you need to pay attention to, well, my screen is cluttered. I'm gonna erase this and move on to item number 13. Item number 13. So let me erase this. And by the way, you can just create groups, keep in touch with your lab partners or whoever in the class, and you can virtually collaborate on how to proceed with the calculation. Now, moving on to 13, all right, item number 13, we need to calculate the pH of our power solution, all right? And the equation we will use is what we call Anderson-Hasselbalch equation. I'm not going to go through, you can read that in the background procedure, what Anderson-Hasselbalch equation. read in the text, or go to YouTube what is Henderson-Hasselbalch equation. I'm sure you will use in your exam. So for line 13, we will make use of these values. pKa, all right, this is from, let me just give you an idea of what is going on right here, page, all right, from page 149, or even the one we did before. You should be able to find the Ka, all right, the Ka, all right, from page 149. You can look at and say that this is the pKa. That will be the value you will plug in here. Look at where the arrow is going. Look at where the arrow is going. On page 149, you have the pKa of potassium hydrogen thalate. Potassium hydrogen thalate. Now, from the Henderson-Hasselbalch equation, the acid and the base comes from here. So this is the molarity of the acid will be your denominator, all right? For your numerator, it will be line 12 here. From line 12, it will be your denominator to do it, to find the line 13. This is for line 13 here. All right, this is for line 13 using this equation. How do you change the, you don't need to change to Ka. This is the pKa of our what? pKa of the thallic acid, potassium hydrogen thalate. From page 149, you have the value there. You should be able to find the value for 12 here and value for 11. 12 and 11 will take care of that. For calculated, somebody may be having a question. Can you go over 12 again? Yes, I can go over again 12. All right. 12 goes hand in hand to with 11. All right. I'll have to pack up all the way to line 11. All right. In line 11, or to start off with, I should have just erased that. Let me just see if I can erase this so that it's clear. All right. I'll pack up to line 11. Remember, okay, remember you started off with a known number of moles of hydrogen thalate. All right. So if you know the number of moles of hydrogen thalate, write down that. I walk you through that line 5. Say if it is XX, all right, let's say if it is XX, I'm just gonna pick some numbers here and say, let's say this is line 5 is XXX moles, all right? That's the number of moles of KH or KHP. To find the molarity of the acid that is remaining at this point, it is no longer the acid alone. It is now the acid in the Pava solution. Remember, Pava solution has conjugate base and conjugate acid, number of moles. So you have moles of the acid in the Pava and you have the moles of the acid. This is my Pava right here, and I should have what? Number of moles of the acid, number of moles of what? Number of moles of the base. So if I started with the acid, I'll have to convert half of it into the conjugate base. So these are minus now number of moles of NaOH. You should be able to find the number of moles of NaOH. So if I do this right here, this calculation for line 11. I know what I started with the number of moles of K. If I subtract that, it will give me moles of the acid remaining. Divide by what? Divide by total uh, volume, all right, volume in liters. What I have here, right here, all right, what I have here is to find the molarity of the acid, the molarity of the acid. Let me circle this so that you see what I'm talking about. This equation right here, what I just went through, is to find the molarity of what? Molarity of the acid. How many moles of KHP did you start with? You should know that. Minus the number of moles. This should have been the number of moles of acid. All right, this should be the number of moles of the base. So that is the number of moles here. Should be the number of moles. So a note here, and I'm gonna erase or just type right here. Number of, let's say, number of moles of NaOH, and that will take care of that. It's gonna just give us, I didn't erase that. So that's for the acid. Now, having gone through that, what will happen to number 12 now? What do you have? Number 12 is when you add NaOH, is a strong what? Is a strong base. And the total number of moles of NaOH added into the weak acid will convert the number of moles of the weak acid to conjugate base. So basically, the number of moles of the conjugate base over the total volume. So the total volume here is this for line 12, all right? It is basically number of moles of conjugate pace. This conjugate pace is the same as or it's the same as moles of NaOH used to prepare what? To prepare the power solution. Divide by total volume in liters. That is how you find the molarity of the pace. Thank you. So we can move on now. So this is what you need to do for 12. Let's move on to 14. 14. You need also to refer to the data to the procedure on part 3, preparation of the powder of acetic acid. I'm just gonna erase that. All right, and scroll this up here so that we can see. Powder solution, part 3, preparation of the powder acid. And please look at the procedure as well. There are some numbers you will be required to use, all right, in order to accomplish successfully calculation and get the required number. For example, line 14 right here, calculation of the pH. Acetic acid is a weak acid. Look at again on page 149, you are given the pKa file. You should be able to find the Ka. I don't want to write down the equation again for Ka. You should be able to find the Ka of your acid, so that if I want to find the pH of acid, so I'm gonna write here 14, pH of this is a weak acid. All right, understand that this is a weak acid, and hydronium concentration is given by hydronium concentration H3O plus hydronium concentration will be given by the square root, okay, it should be square root of everything under square root, the Ka times the concentration of what? Concentration of Ha, that is the acetic acid. This is the concentration of acetic acid. Now, let me ask you this. Please look at the procedure again for, part 3. And what is the concentration of the acetic acid used in preparing the powder solution? Look again on part 2. What is the concentration of the acetic acid used to prepare the solution? Read the direction, please. I'm gonna unmute everybody. What is the concentration of the acetic acid? All right, Miles, thank you. You got it right. All right, but significant figures, please. It is 0.100 molar. All right, so you need two more zeros for concentration. So, having said that, let me mute everybody just in case there's some background noise. We don't want any interruption. So, having gone through that, that is the file you will need here. The Ka value you'll have to determine from the pKa value from page 146, the concentration of the weak acid. You know this means concentration of the weak acid. From the procedure, you have to know the value. That will give you now the hydronium concentration. And now you plug in your regular equation, which you're familiar. That is the hydronium concentration. Hydronium concentration. All right. This is concentration is that, right? So that is line 14 actually. That's line 14. The literature going on here is from the lecture. It's not somewhere in the book, you know, or it's assumed that you just cover this section, you are past this section, and you just have to figure it out how to find the pH of a weak acid. All right, from the Ka value, and it's, you know, you're not gonna take negative log of 0.1 and say that this is what we find out. No, 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 no. First of all, this is a weak acid, and we do not just dive into this equation. And by the way, this should be negative. My apologies. It should be negative. That should be negative. Remember that, negative. I'm done with equation 14. I'm just gonna erase this again, just like we did. And we move on to 15. On 15, how did we prepare, or what is the molarity of the acetic acid? You got to read that. From the procedure. All right. All right, this is 16. Now, if you look at, all right, You don't have to do calculation for 15 and 16. You got to read the procedure. Now, for number 17, all right, number 17, you know that it, remember before mixing, you are dealing with acetic acid alone. How do you find the number of moles of acetic alone? You know, number of what? Number of moles equals to molarity times volume in liters. Again, this is from the procedure. You got to find out the molarity. It is in the procedure. The volume for for acetic acid here is in the procedure as well. This will give you the total number of moles to start with. We will convert half of this down the line into conjugate phase of the acid. So we need to know the total to start off with of the acetic acid. Molarity of the base used, all right? All right. Again, for line 18 there, from procedure like that. That's what you need to see procedure. All right. Maybe I should say see procedure. That's what you need to see for line 18. All right. You got to see the procedure for that. You got to see the procedure for line 18. Molarity, volume of NaOH used. Again, you got to see the procedure. Moles of NaOH. All right, you know this. This is given by molarity times volume in what? In liters. So you have the information. All right. You need to calculate the pH of your powder. Just like 11 and 12, all right, 11 and 12, 11 and 12, you'll proceed the same way as that step 11 and 12. For 21 and 22, it's the same way. How will you proceed for that? For 21, I'm going to erase everything you see here. If you are taking the notes so that I write the setup for 21. I will erase what you see on the screen here so that I get a space to do 21. For 21, all right, 21, species molarity here. Molarity of the species protonated in the conjugate base conjugate power. In this case, you need to find the number of moles of remaining. In this case, it is given by number of what? Number of moles of acid remaining divided by volume of total volume, volume in liters. Total volume because you are adding acetic acid and you are adding, no, you have acetic acid to start with and you are adding NaOH. You should be able to figure out the total volume at this point. Why am I saying remaining? You got to do the math that if I know the starting number of moles of acetic acid before I add, how many moles of NaOH am I adding into this acetic acid? The number of moles of NaOH being added will consume the same number of moles of acid you started with. And It's not neutralization in this case, but it will convert to the conjugate base. So it's not about neutralization, no. The number of moles here will convert the starting number of moles of acetic into the conjugate base of acetic acid, which is the acetate in this case. So whatever will remain, we will use to determine the concentration of the acid, which is equation or item number 21, item number 21. So remaining, you got to remember that the added NaOH will convert the starting number of moles of acid into its conjugate base, which is what? Which is the acetate ion. Acetic acid, acetate ion conjugate base. Total volume by now, you should know what it is. This will give you what you need for item number 21. Any question on 21? I know it was a little bit, we had to pack up for 11 and 12. There is no question. I'll move on to 22 here. And in this case, it will be the number of moles of NaOH added. It's the same thing, or number of moles of NaOH added is the same as the number of conjugate base. It's just direct way of looking at it. Conjugate base, just give you an idea of what the total volume. This will give you the value for what? For item number 22. Number of moles of NaOH, don't worry about NaOH because the NaOH added will no longer be NaOH in the solution, in the powder solution. It will be the number of moles of the conjugate base, conjugate base. With that, we will use now Anderson-Hasselbalch equation. Anderson-Hasselbalch equation, of which here pKa, pKa 49 will be your, all right, will be your what? It will be your value which will go on this Anderson-Hasselbalch equation right there. And if I look at page 149 for acetic acid, all right, it is 4.792. That is the pKa of acetic acid. Excuse me. So now, what we need to do is plug in the Anderson-Hasselbalch equation for item number 23 here. For item number 23, you use that equation by taking whatever you have for the acid. This is line, from line 21. And the conjugate base is the item you'll get from line 22. Line or item number 22 there, conjugate base, conjugate acid. So if you are numbering them, this will be very clear. It will be very knowledgeable, and that's why I always say, show your calculation, because if you number them the way it is, and then I know, oh, item number 23 is this, rather than just, having calculation on the blank sheet of paper. I don't know which calculation is for what item. But if you label them the way they are, I know, you circle and say this is set up for value in box number 23. It's look nice, and you set the Anderson-Hasselbalch equation. That how I ended up with 23 is pH equals to pK, and then you plug the values in there. That take care of section 3. Section 3. All right. Any question? All right, let's see. Move on. I will I'll erase this, and I will erase this so that I move on to the next section. So I'm just gonna erase this right here and move on to the hydrolysis of a salt, phosphate, powerful, phosphate, powerful. Before we just go through hydrolysis of a salt, you should know which one is an acid, which one is a base in this case. Please, using the chart feature, can you tell me which one is an acid, which one is a base in this case? Which one is an acid, which one is a base? Because if we don't identify which one is an acid, it will be very difficult for us to move forward. Please, which one is an acid, which one is a base? Which one is an acid? Let's see. The top one is an acid, bottom one is a base. Good. Thank you, Patton. That's right. The top one here is an acid. The top one here is a base. Forget about the sodium. Sodium is just, to balance the charge. Remember conjugate acid-base pair, where if you remove an hydrogen, you end up with a conjugate base. If you add an hydrogen, you end up with a conjugate acid. So removing one hydrogen here will leave us with only one. So this is the base and this is the acid. It is crucial in the sense that when we get to Anderson-Hasselbalch equation, we got to know which one is the acid, which one is the base. So how are we supposed to calculate the pH of each one of them? If you look at line 24 here, all right, before we come to line 24 and line 25, all right, before we come to line 24 and line 25, you need to find the number of moles of each one of them. We're gonna jump the gun for a minute here and go to 26 and 27. All right. Number of moles here is, mass over what? Mass over molar mass. So number of moles is given by mass of each one of them in grams, divided by molar mass of each one of them. You need to use these in order to find the number of moles. So number of moles you see here, for each one of them, this will be applicable to line 26 here and line 27 right here. So how will I find the mass? You are given, look at page 149, please. Look at page 149. You have the molar masses of each species. Molar mass of the acid is 137.99. Molar mass of the base is 268.07. You have the molar masses. Do you know the mass of each salt? Yes. This is the mass of each salt. This is the mass of the acid species. This is the mass of the base species. So the acid species in this case is this one right here. As Amy pointed out, that is the acid. And this is the pace right here. This is the pace. So at least you know now how to, where the numbers will come from for line 28 and 27, line 28 and 27. That is what you need to find out in terms of moles of each species. Before mixing, all right, before mixing, what will happen here is we need to find the molarity, all right, of each one of them. It is assumed that you dissolve in certain volume. Remember, molarity is number of moles over volume in liters. You are preparing a powder, so you have separate masses of each one of them. The solutions were prepared in different, all right, in different beakers. Say 50 ml beaker, you have these two solutions. How much volume of DI water did you use? Look at hydrolysis of a salt. Look at hydrolysis of a salt, because if we don't know the volume of each one of the solution, there is no way we will find the molarity, you know, for number of moles. Number of moles, you need to find the number of moles, all right? Molarity is given by the number of what moles of volume in what volume in liters, volume in liters. So what will happen here is the equation, all right? This is what we need to find out right here. This one right here is for line 28 right there, and line 29 right there. So where is the volume of each one of them? What is the total volume? Not total volume, we haven't mixed yet. What we given, you should read there and tell me what is the volume. Read the direction, all right? It should be somewhere in the middle. I'm gonna read that. Add this mass to dry and 50. What is the volume in liters of each one of them? What is the volume? Somebody just responded. Let's see. Uh, each solution, it is not, I don't think that is Daniel Edwards. I don't think that is what it is, because if you think about it, measure out 50 ml of, we are measuring out an already prepared solution, which means we have to prepare the solution fast from the concentration. Look at the mass measured out, and the direction should ask you dissolve in what? Once you dissolve, you make a solution which you will now measure out the 30 ml. Look at. Yes, thank you, Miles. All right, good. If you look at the top of the page, it says dissolve the acid in 50 ml water and swirl the solution to completely dissolve. So you are weighing out the solution, the acid and the paste in a weighing board, and you dissolve in 50 ml. And line 28 or item 28 and item 29 is to find the molarity of the phosphate solutions before, all right, before mixing. The 30 ml is just you are now taking out of the 50 ml measure out, we'll measure out, or rather, out of the 50 ml solution prepared for each species, we'll measure out 30 ml to prepare the powder solution. So what we'll need here is the total volume of deionized water for each species used to dissolve the given mass of each one of them. So it's a function of how many ml of water was used to dissolve this, how many ml of water was used to dissolve this to find the concentration of, all right, concentration of each one of them. This is before mixing, all right? That is before mixing. So for most part, you'll have to go back to the procedure in order to figure it out what is going on. So here, change the volume to liters and you proceed with what? The number of moles, you already have the number of moles of each species. You know the volume of each species, all right? And you will now proceed to find the molarity. If you look at this now, molarity of protonated weak acid, weak paste in a powder solution. Powder solution is, all right, powder solution is obtained by now taking the 50 ml. If you look at the direction part C, all right, on part C, one part C, to prepare the powder solution, you have measured the pH of the solution and recorded in the data sheet, all right? This is the measured pH of the powder solution. But first, how do we find the molarity of each species? Molarity of each species. If you look at part D, look at part D on page 146. Look at part D on page 146. Part D on page 146 states that if you did, as you did above, you want to create 60 ml of powder solution from 2 solutions. So that means we want to do what? Make a powder solution with a total volume of 60 ml. How do we end up with 60 ml? By measuring out 30 ml of what? 30 ml of each solution. That is 30 ml of hydrogen thalate and hydrogen thalate as the base and the acid. That's where 60 is coming from. All right. Now, let me erase this so that I'll walk you through number 30. When I erase this, right here, oh no, I meant to erase this right here, this curve, and I will walk you through on how to proceed with item 30. When you mix the two, all right, remember total volume is 60 ml. So if it is 60 ml, if I know the number of moles or I know the concentration of the acid concentration of the base from part A here, all right, concentration of the acid concentration of the base, what I'll do is, listen, I will write here, first of all, say number 30. Let me just write here. It's gonna be a long, I'm gonna write that here so that you take the notes from the molarity equation. Okay, you know, number of what? Number of moles equals to what? Equals to volume or molarity times volume in what? Volume in liters, volume in liters. So that's what I'll put in there as the volume in liters. So that's what I'll put in there as equation. So you need to find the number of moles of from this is in 30 ml. 30 ml. Remember, you are taking 30 ml of each what? Of each solution. So the volume in liters, you know the molarity of species. You have calculated that. I know the number of moles of my acid. You'll do the same thing for what? For the base. So if I want to find the molarity of the acid, all right, it will be now molarity equals to number of moles remember, we are trying to make a full an acid of total volume of 60 ml. So you're gonna change that to liters. What is the total volume? Direction call you to do that. So I got to move on real quick. You'll do the same thing for what? For line 31. For line 31, you use the molarity. I'm just gonna change the equation for that one, number of moles, and then here it will be the pace right here. It's just gonna change the pace. That's what you need for 30 and 31. It's the same thing here, but you'll have to change that to moles of the pace, moles of the pace. Any question on 31 and 30? I got to move on. Now, for line 34, you use Henderson-Hasselbalch equation, and I want to just fast forward. By now, you should know where to get the values. Once I know for 31 and 30, these values, you'll just plug it in Henderson-Hasselbalch equation. pKa is on page 149. Look at page 149. We will use the pKa, which is 7.198. And you plug in the values, That's what you will need for pKa for the acid, and you plug that one at the 2 to get 34. Any question? Any question? All right. Everybody's fine? Any question? I muted everybody. Any question? Oh, yeah, somebody is asking, Mary's asking, what is 7.98? This is, let me just be clear. This right here, let me erase right here. This is the pKa value. If you look at page, from page 149. Look at page 149. P Ka equals to uh 7.198. That is the value you would need for that is the value you will need for this. That is the value you will need
Okay.
for the equation here. You see that? Everybody, you see that? That is where I'm getting that. And this value will just come right here for the acid, and this come right here for the base. And everything right there will be the calculation for that. That is why I was saying 7.198. That is the pKa of the acid. Any other question? If there is no question, I'm gonna move on to the next section, which is all right, the next section, which is testing the pH of the power capacity of a solution. All right, testing the power capacity of a solution. I'm just gonna erase these right here and scroll up. All right, we see, I wanted to erase these right. Erase these right here. And we're gonna move right here. 34, you did that. Now, 35 is testing the pH of the solution. Power, determining the power capacity of your solution. In part three is determining the or testing the power of phthalic acid. This is for phthalic acid. This is for the acetic acid, and this is for phosphoric acid. The change here, all right, change in pH 35 is, this is for the power solution compared to the acid. The value here corresponds for acid. What's the difference between this number? This is the pH of the acid. This is the pH of the base. What is the difference for line 35 and line 36? It is a function of these numbers right here and the pH of a power solution. I'm on cruise control right now. To get 35 and 36, what is the difference between these two and the pH of the solution? Get that? Set up the equation, you're gonna get that. All right, volume in liters of the solution used. How do we proceed with testing of the power solution? Volume of the power solution used. Read the procedure. Part 3, from part 3, you should have, listen, you should have what is stated or what is the volume of each. In two separate P gasket, 1.5 15.0 ml. Look at the direction on page 146. In two separate P gas, 1.0 ml of ACl and 1.15. So 15, 15. All right. Take the line 2, part 2. Take phthalic acid powder you prepared above and split it into 2 clean, dry pickers. 25 ml into each picker. You may discard the remaining 10 ml, remaining 10 ml or so, in appropriate container. So you should know how many ml. By reading that statement, if you don't read that, it's gonna be very difficult to figure it out, which one you are using. So in part 3, page 146, line 2, it is state the ml of the power solution. How many ml did you use for the power solution? Please use the chat window on, please use the chat window on, all right, and tell me what is the volume. You got to figure it out what it is. What is the volume of the power solution used to test? Can you use the chat window? Look at the direction. Did you go over 24, 25? Did you cover number 24, 25? Did I cover 24, 25? Let's see. 24, 25. Yes, I, oh, 24, 25, probably maybe I didn't cover that. Yes, I don't remember going over 24, 25, 24, 25. Let me back up before we come down. I think we are done with 35, 36. We are done with that. I was in item number 37. We'll pick up from here. Let me go back to 24 and 25. 24, 25 is weak acid and a weak base. So if this is the acid right here, we know this is the acid, we have to find the hydronium concentration. All right. For the acid, let me just use this. I'm going to write it down here. I should have just had, you know, a different, I should have had one document so that I type for that. So what I'll do is for acid, that is NaH to PO4, like that, H2PO4, that is an acid. All right, this is an acid, right? This is 24. We are dealing with an acid. This is a weak acid. Shall I say weak acid? We know that is an acid. So here what we will do is determine the hydronium concentration first by saying hydronium concentration by saying the 23. This is hydronium concentration, H plus, like that, equals to what? Equals to the square root of Ka times what? Times the of the acid. Let me explain what is going on here. On page, look at page look at page 149. On page 149, you can rearrange that Ka to form the what? To form, rearrange the equation to get the Ka. Use the item on page 29 to get the Ka. Now, concentration of the acid, it is from line 20 or molarity P4 mixing, that is 28 here. Line 28 P4 mixing, calculated pH. How will I calculate the pH of my solution right here? You got to know how many grams. If I know the moles of each species, what is the volume of each species? The direction will tell you how many ml of each species you use, or how many total volume. So this is the molarity of each of the acid. This is the molarity of the acid. By dissolving what? Dissolving this in known volume of the acid. From here, I know the hydronium. I'll now use this equation, which is pH equals to negative log of equals to negative log of hydronium concentration. Hydronium concentration, that is 3, and then positive. You'll get from here. So this hydronium is obtained from this equation. Ka from page 149, you can rearrange that. This is from the calculation. How much did you dissolve? In what volume of H2O? You've got to get the concentration, change that volume to liters, all right? You got to know how to find the molarity volume in liters. Any question on 24? This is 24, it is an acid. This is the calculated for an acid. So that you notice the difference, I'm just gonna do 25. 25 here. This is H P. This is NaHPO4 Na2. Should I say 2 here? 4 like that. This is weak what? Weak pace. And you are expected to remember that K what? K A times what? Times KP equals to K what? KW. And this value, you know, at what? At 25, we'll assume that at 25 degrees Celsius equals to 1.0 times 10 raised to negative 14. Not 17, but I meant to say 14. KW, you know KW, this is KW right here. So if I want to find, since this is a weak pace, I want to find the KP. Therefore, KB equals to what? KW divided by KA. You should have KA from number 24. Or yes, you should have the KA from number 24. So that once you have this KP, we will now talk about the hydroxide concentration. So hydroxide concentration here, that is hydroxide concentration, all right, is given by the square root of Kb times the concentration, all right, concentration of the base. Here, concentration of base, right there. How will you find the concentration of the base? We did earlier on. Let me see if I can move this. If you know the concentration of the base here, molarity phosphate P4 mixing, you should have the value for line number 29 here. This is what you will put everything under the square root. It will give you the concentration of hydroxide. Then from there is pH plus POH equals to 14. Therefore, pH, let's say pH, POH, let's say POH equals to negative what log of hydroxide concentration. This is H negative. You know the hydroxide concentration right now. You know the hydroxide concentration right now. pH, therefore, pH of the solution is obtained by subtracting POH from 14 minus POH. Thank you for reminding me that is the line 25. It is a pace, it's a weak pace. And you are expected to remember from the lecture the relationship between KW and KW and KW, KA, and KP. When you are dealing with the base, you don't just take the negative log. That will take care of line or item 24 and 25. Any other question? If there's no other question, I'll exit here and just fast forward to where we are or where we were. We were on item number 37, of which you can get this from 37. You will get from the what? By reading the procedure, please write on the data sheet in your lab manual from the procedure. 38 from the procedure. Volume of strong acid, strong base added. All right. It's gonna tell you the volume number 37. How many volume added, volume of the base added So that it's gonna give you the calculation for on item number 23, not 37. All right, that's 37, 38. Volume of the strong acid, strong base added, full number of moles of hydroxide added, calculate the power capacity. If I look at that value there, since some values are missing in there, I got this data from instructor teaching the same course. What basically means he is the pH, number of number of moles of hydroxide added, change in pH, change in pH. So if this is the pH after addition, change in pH 25, 35. To find the number of moles of hydroxide added, number of moles to see the change. From number 37, 30 what? 39 and 40 here, you're supposed to measure, let's see, to 25 ml of potion power out. If you look at line 3, look at line 3 on page 140, please. Look at line 3 on page 140. Can someone read for me, please? Line 3, can someone read? Can I unmute? Everybody's unmuted. Can somebody read for me page 146? Item number 3. Somebody read for me item number 3 on part 3, page 146. I'm waiting for somebody to read for me item number 3, page 146, part 3, step number 3. It is bolded 1, 2, 3. Somebody to read for us item number 3, please. It's gonna unlock what is going on page on number 30, 39. All right, and even number 39, 40.
To one of the 25 milliliter portions of the buffer, add 2.5 milliliters of the 0.1 molar HCl solution. Stir the mixture and then measure the pH of the resulting solution. To the other 25 ml portion of the buffer, add 2.5 ml of 0.1 molar NaOH. As above, stir and then measure the pH of the resulting solution. Record the data on your data sheet.
Thank you. Thank you. That will now, I wanted your attention to go there because the measured pH is what they're talking about right there is this is the measured pH, the measured pH after addition. Now, the question is the volume or number of moles, volume of the strong acid, strong base. For 39 and 40, volume of strong base, strong acid. Strong acid is HCl. From that statement you just heard, what is the volume of HCl? What is the volume of NaOH used? It is in item number 3 right there. So 39 and 40 is in item number 30, item 3 on page 146. It clearly states the volume of HCl used. That is a strong acid. The volume of base. That's it. Now from there, if you know the volume and concentration of each one of them, it should be very easy now to look at line 40. That is how you figure it for 40 and 39. 40 and 39, look at the procedure, line number 3, part 3 on page 146. I want just to show you on number 41. It's easy. 41 now, if I know All right, most of hydronium and hydroxide, you know, from the molarity, number of moles is given by what? Number of moles is given by the molarity. You know the molarity of the acid used. All right, acid or base times the volume. All right, volume in liters. Again, this is from step number 3 on page 149. You know the molarity of the strong acid, that is hydronium. Hydronium is the HCl. Hydroxide is the sodium hydroxide for line 41 and 42. I should have even say here and 42. I should have say and 42 to show you how to find the number of moles. This is from page see page 146. All right, line what? Line 3 or step 3, you want to call it. That's what you need to remember in terms of 41 and 42. 41 and 42. All right. For 46 and I mean 43 and 42. All right. 43 and 42, you have that. Let's say for do what? 43. 43 and what? And 44. C equation. C page 144. See see page 144. Everybody turn on to page 144. Everybody turn on to page 144. Everybody turn on to page 144. I want you to look at the equation in the middle. There is an equation at the middle of the page where it states that power capacity equals to the number of moles of hydronium added or the number of moles of hydroxide added. You should be able at this point to have the value from 41 and 42. That's the number of moles of the acid, number of moles of the base added. All right. And divided by change in pH over divided by absolute value. All right. In change in pH of the change in pH, all right, over volume of the powder in liters, volume of the powder. So what that means is absolute value for change in pH. Let me show you where change in pH. This is where you will get change in pH, make it positive. That is why you have the absolute value in the denominator times the volume of powder in liters. Read the procedure. How many ml of the powder solution did you use? Change that to liters. And remember, it's going to be absolute. That multiplication, there is multiplication between volume and the powder solution. So just make it positive. Whatever you will use for change in pH, for change in pH, it comes from these 35 and 36. Total volume of the fiber, you should have that. You should have the number of moles. That will take care of line 43, 44. Any question on 44, 43? Move on. Did I mute everybody? Let's see. I didn't mute you. Wake up. Did somebody sleep? This is the longest one. We have, we have calculation, as I said. It's the longest. Let's see. For second to last, we're almost done. Second to last is the power capacity of power testing, the power capacity of the tralic or acetic acid for acetic acid. So we'll do the same thing, just like P4. All right. We'll do the same thing like P4 in 44, 45, the difference. You're gonna find the change in difference right here. This is the final pH of the powder solution. This is for the acid, this is for the base. Volume of the powder used in liters, read the direction for 47. It tells you the volume in ml for the powder solution. I mean for the acid. What is the ml of the acid used to prepare the powder? For the eighth state, what is the ml of the paste used to prepare the solution? All right, change that to liters. You got to change to liters. I know in the procedure, it is given in ml. Read the procedure for 48 and 47. Now for 49 and 50, look at the procedure for 49, the procedure for 49 and 50. It's the same thing, you repeat. Do you remember somebody read for us the volume of NaOH and volume of HCl? Do you remember? You should remember that. It's just like a minute ago. It's 2.5 ml. Still same NaOH, still same concentration. And calculate the power capacity. Use the equation on page what? Use equation on page 146. We are using still the same hydroxide and same hydrochloric acid for 49 and 48, 50 and 52. I'll say see previous section here, 41, 42. I can say right here, it's the same thing. All right. And you come down here, it's the same thing. Change in pH, change in pH. And then you determine the capacity of pH capacity of your phosphoric acid. It's the same thing right here too. All you have to do is read the procedure, Calculating power capacity, most of hydronium is repeating over and over again. If that is done, if there is no questions, that marks the end of the calculation part for the experiment. I will post all the remaining labs so that you can work on your own pace during the pre-lab by reading the procedure. You can at least attempt the pre-lab, okay, before the lab session, So always between 5 and 6 before we get started with the lab. I have office hours. You can just call in. I will schedule a meeting. You may have seen a scheduled meeting for 5 to 6 and you're wondering what's going on. That is office hour. In case you have a question before lab, you can come in and say, oh, I forget how to do question, whatever. Or if you have any other agenda you want to bring to my attention, you can just use office hours. You can email me, all right? You can email me and I'll try to respond within the shortest time possible, Other than that, the class is dismissed. If there is no other question, all right? If there is no other question, I will end the session. I want to say thank you for tuning in. We will meet next week, same time. We'll meet next week, same time. 6 o'clock is when I start officially going through the data sheet and calculation. So remember, what is due next week is, or during the course of the week, is the pre-lab for next week. I'm gonna share that either tomorrow or over the weekend. All right. The post lab, which is already available on Canvas, and the data sheet and calculation for this lab, which I went through today, all right, is due by next Thursday, just the way we have been doing during the course of the semester, all right. The class is dismissed. If there is no other question, if you have any other private agenda, please send me the email. With that, I will end the